Okie dokie. So we've got our exponent chart out. We're going to use that to help us with the notes for today. But the first thing that we're going to look at is the graphs of our new functions for our new unit. Our new unit is exponential and logarithmic functions. And exponential and logarithmic functions, they are inverses. When you have an inverse, how can you easily make, when you have a function, how could you easily make the graph of an inverse? What do you switch? No, you just switch X and Y. So if you have a function, you just switch X and Y, and you can make the inverse. So these are different than, like when we made the exponent chart, this was X to the something power. This is a little bit different because when you have an exponential function, that means the X isn't the base, the X is the exponent. And so the base could be any number. We're going to graph with a base of 2 right now. So we're going to start out, and just to kind of remind you to make our table, these are like 2 to the -2 power, 2 to the -1 power, 2 to the 0 power, 2 to the first power, 2 to the second power. That's what those are if we're plugging those in. So the easier ones are when we plug in 1 and 2. So what is 2 to the first power? What's 2 to the first power? 2, just 2. So that one's easy to fill out. And then what about this one? What is 2 to the second power? 4, those are easy. What is anything to the 0 power? No, it's not. No. Type it in your calculator so that you remember 2 to the 0 power. It's 1. Just to be sure, type in 10 to the 0 power. It's also 1. Anything to the 0 power is 1 every time, all day, every day. So that means that it doesn't really matter what the base is. 2, 10, 11, 47. Anything to the 0 power is always 1. So that means unless you're shifting it left, right, or up and down, every single one of these functions will always have that point on it. Okay, so for the negative powers, y'all probably don't remember, but you can fix negative exponents. And to fix a negative exponent, you can rewrite it in the denominator and it becomes positive. So if we ignore the negative for a second, what would just 2 to the first power be? 2. Okay, but we have to write that in the denominator. So it becomes 1 over 2. And we know down here that 2 to the second power is 4, but it has to rewrite in the denominator to become positive. So it's 1 over 4. That's a property that we're going to use quite a bit on the back page of these notes. is that idea that anything with a negative exponent can be rewritten as a fraction, or if it's written as a fraction, so like 1/4 is the same thing as like 4 to the -1 power. All right, we're going to take these and we're going to go plot them. In fact, we could do one more line. Let's do 3. So what would 2 to the 3rd power be? And you have an exponent chart. 8. So we've got a couple points that we can plot. I'm going to start with the right side because those are nice, pretty whole numbers. So I already have 0 and then 1. And I can have 1 and then 2, 3, and 2 and 4. I skipped that one. And then 3 and 8. So the graph stops at 7. So it'd be like 1 more above that. When I go the other direction, I'm just going to have to estimate. So it says that at -1, I'm at 1/2. So I'm just kind of putting it in the middle. And at -2, I'm at 1/4. So it's like right there. And just using symmetry, because I hope that you guys notice that the table has symmetry. So we've got 1 in the middle, and then we have down, it goes 2, 4, 8, and then up, it goes denominators 2, 4, and then what would 2 to the -3 power be? 1/8. So, and if I had to do that, if I had to go to -3, 1/8 is just really like, it's going to be hard to keep getting smaller. And so like to the -4 power, it's like 1 over, let's see, 16. No. 1 over, yeah, 1 over 16. And then we've got 1 over 32. These numbers get really, really tiny. So like, how much closer to tiny can I get? It basically is going to look like I'm touching 0, but I'm not. I'm just getting really, really close. I can connect the dots. And I will make sure and put an arrow. And then to the left, I'm getting so close to 0 that it kind of flattens out. In fact, these graphs actually have an asymptote because I'm never actually going to reach 0 on the left. So we have an asymptote. So if you're using your pencil, you want to make a little dash line, it's going to be hard to see. Or if you have a highlighter, you can use a highlighter and make it a solid line. Or if you have a colored pen, you can do a solid line if you have a colored pen. But right at 0, there's actually an asymptote because your graph never touches. An asymptote is somewhere that your graph gets so close, but it can never actually touch. If you've got a pencil, it needs to be a dash line. If you're doing it in a different color, you can put a solid line if you'd like, because I'll know that you're telling me it's something different. So to know what that line is for an exponential, it's always whatever is the plus. So here, there is no plus anything. So it's like plus 0. That is where your asymptote goes at 0. So if you want to give yourself a note down here, the K is where the asymptote is. Asymptote is a funny word. ASYMPTOTE. Asymptote. There's like a silent P in there. Asymptote. The funny word. So you can always know where the asymptote goes by the very last number. If there's not one, it's always at 0. A lot of times it's just at 0. For domain and range. So for my domain, that goes with X. X is left and right. This graph is going to go on forever to the left. It also goes on forever to the right, just growing. So it is all real numbers. For my range, my graph goes up forever because it is pointing up. Does it go down forever? No, there is an asymptote. It stops my graph. It says your graph can get really close to 0, but it's never actually going to touch. So you use the asymptote to help you figure out your range. So it says that my graph is above 0. So we're going to say y is above 0. You can never touch 0, so you cannot put the equal to. These graphs are not equal to, it's just greater than. We have not finalized your quiz, but it is highly likely, because we've talked about it, that our goal, like our idea is to have a question basically like this, where we give you an exponential, we give you a graph, we give you a table, and then we say, like, use this and graph your inverse. I believe it's graph your inverse. Let me see. Okay, so again, we haven't finalized anything, but this is like our rough draft of our quiz. We're going to have you graph the function, which would be something like this. Could be 2 to the x power, 3 to the x power. And then we're going to have you graph the inverse and state the domain and range. So we just did one. If it was a 3, it'd be no more difficult. You would use your exponent chart to help you. So to graph the inverse, we put on the line how you figure out an inverse. So Lenina, what do you do to make the table for the inverse? Hmm? You told me what to put in the blank. That's it. So we're going to come and we're going to make, nobody knows how to do the logarithmic function, right? Anybody know how to do the log base 2 of something? No, it doesn't matter. It doesn't matter. You don't have to know any of that to be able to make this graph. But to make this graph, all we're going to do is take this table. We're going to switch the x and y. So let's do that. We're going to switch x and y. So remember that my advice when you have to switch them, just work on one column at a time. So you could do the left column and transfer it all at once. Since we're switching things, we also have to switch the asymptote. Right now, the asymptote looks like this. So if you're switching x and y, then show me, like with your hand, air draw it. What is it going to look like if I switch it? 2 of you showed me. You can air draw it with your hand, or you can show me with your arms. How is it going to go? Yes. And as silly as those things feel, that's how we remember stuff. When you actually make a movement with your body, you remember things. So yes, it's going to switch to be up and down. So I can go ahead and move that over. So if on this graph, it goes and it's at 0, where's it going to go on this graph? 0, same place. So I'm going to go draw that on here. And the way you know what that asymptote is, although we're not going to spend a whole lot of time graphing. Since we switch x and y, it goes with the x. And here it's like plus 0 because there's not anything. So it's at 0. We're going to plot those points. So just like we said that on this one, it doesn't really matter what you are. Everybody has the same middle point. Same thing over here. I mean, this is also going to be the same. Doesn't really matter what the base is. Always going to be that same point. So we're going to go plot these points. So I'm going to go over 1 and it's at 0. And I'm going to be quiet, but I'm going to plot the rest of these. It's easier to graph the stuff from the bottom first. Over 2, up 1. Vincent, I have to keep changing the stickers. So when we do the ones with fractions, don't stress out. Some of y'all really stress when there are fractions. To graph the first point above the 1, 0, it says that at a half, we're going to be at -1. So you just go over a little and then down to -1. And then you go barely any, and then it's down at -2. I'm going to connect these dots just the same. And it goes straight down. So I'm never going to actually touch 0. I'm going to get so close. Because the X and the Y switch, the domain and the range pretty much switch. So now for the range, my graph is everywhere up and down. So my range is all real numbers. And since I do not go on forever in the X direction, I have to say where I start. So my X's are going to be bigger than 0 because my graph is over here. It's X's that are bigger than 0. Again, something like that is highly likely to be on your quiz. Let's get that question right. That's also like the first question on your homework for today, where I give you one. It's basically the same. It's just 3 to the X power. So let's make sure we get that correct. Moving on. So this next section is asking us stuff about exponential growth and exponential decay. Oh, also, before I move on, if we were going to identify any kind of transformations, they move in the same, they have the same behavior. So whether you're talking about log or an exponential, the number in front of the base, that can stretch or compress you. It can also reflect you. Those are the transformations we look for there. Anything with the X value moves you left and right, but in an opposite way. And then the K, whatever's at the end, moves you up and down. It's the same for every function we talk about all year. But when we talk about whether or not something is growth or decay, we're looking at specifically the base. And so that's what B is. B is the base. So exponential growth is going to be when the base, or the B, is bigger than 1. So I wrote that mathy, and I'm also going to write it just in words. Bigger than 1. Decay is when the B is between 0 and 1. So B is between 0 and 1. So to figure out whether or not you are growth or decay, you're looking at specifically the B, the base. The base is what holds up the exponent with the X. So you're looking at specifically that number. So when we look at 3/4, is that a number that's bigger than 1 or a number between 0 and 1? Yeah, 3/4. I mean, you could type it into your calculator if you're unsure about the fractions. It is definitely a number that's between 0 and 1. So I'm going to come down here and I'm going to write it. So would that be growth or decay? So I'm going to write it underneath decay so that you know why you picked it. It's decay. So take a look at 2 and take a look at 3 and see if you can identify, are those growth or decay? Oh, I'll write it again so you can see me write it. Do you see how this one is B is bigger than 1? Okay. This one, B is less than 1, but it's also bigger than 0. So it's between 0 and 1. So right now you're taking a look at 2 and 3 to see if you can figure out, are those growth or decay? So 5, is that growth or decay? Growth. 5 tells me it's growth. What about 5 over 2? It's also growth because 5 over 2 is 5 halves or 2.5. So 5 over 2, it is a number bigger than 1. So it is growth. So be careful. Don't just assume that every time you see a fraction that it is decay. Sometimes it is growth. For transformations. So transformations, remember the transformations happen before, with the X, or after. So those are the places that you see transformations. So for this one, the 5, it stretches me. It's a stretch by 5. And what does the 4 tell me? Up 4, very good. For the second one, what does the 1/2 tell me? Compress by a half. What does the -2 tell me? Nope, it would have to be at the very end. It's with the X. Right 2. Which is the same transformation for 3. So we are going to use that information to kind of help us get just a general sketch of what our graph looks like, because that's what's going to help us figure out the domain and the range. So you can do a real tiny graph over here on the side. You just need an X and a Y. So for question number 1, the +4, it tells me that I'm going to go up to 4, and then I have an asymptote. It's at 4. For both the second and third one, they're +0 at the end because there's not a K. So these both have an asymptote at 0. So remember that the number at the very end, the K, it tells you where your asymptote is. For every single one of these, I don't have to look at the graph. I know that the very first point is 1 above wherever that asymptote is. Doesn't really matter. It's 1 above it. Unless I was reflected. None of these are reflected. So first I'm going to start with my growth graphs. My growth graphs go positive forever. So it will look something like that. This is basically like the first one that we drew. Goes up forever. Doesn't really matter what else is going on. These both shift to the right to that point is shifted right to, but it doesn't matter. It's going to have the same shape. We need to have the shape. For this graph, decay graphs look a little bit different. They get smaller, so they go down like that. They go down. Can somebody open the door? That is going to help us figure out the domain and the range. And to be honest, it doesn't really matter whether you're growth or decay. Every single one of these is an exponential, and all the exponential graphs go on forever to the left and right. So the domain is all real numbers. Because our graph goes on forever in both directions. And so here, it doesn't really matter how you adjust your graph. It will always be all real numbers for the domain for an exponential. The only thing that we're going to do is look at where the asymptote is to figure out what your range is. These two are easy because it's just like that parent function that we made up at the top where y is just bigger than 0. But for the first one, it's not y is bigger than 0. What would it be? Very good. Y is bigger than 4. That is pretty much as in-depth as we're going to get to graphing. You just need to know the basics. Down at the bottom, guaranteed to have a few questions on your quiz like this. So probably at least 2 or 3 questions. Oh, I should have also mentioned, another question that I see on your quiz is like a question like, which function represents exponential growth? So that would be looking at that b value and identifying, is it a number bigger than 1 or between 0 and 1? Guaranteed to have a few questions where you have to write in exponential or in logarithmic form, and they can be switched. So when we rewrite one as the other, it is easier for me to rewrite a log as an exponential. And what I do is I make a little swirly thing. And it looks like that. Because that's where I start. And to rewrite it, it's 2 to the 3rd power equals 8. So that's how I would rewrite it. That's what it shows you here. 2 to the 3rd power equals 8. So I want to go through and do the first, or do the logs first. So the one on the left, it's 3 to the 2nd power is 9. And that's it. We're not solving anything. All you're doing is rewriting it. So rewrite the 3rd one that's also a log. Rewrite it. And then I'm going to rewrite it. And we want to make sure we can do it and we're correct. So do that 3rd one that is the log. Skip over to the one that is a log so we can do that one. Those are easier. Again, I find it very helpful to draw this swirly thing. So for that third one, what do you get? That's it. So again, on your homework, on your quiz, I ask you to do that. It is just rewriting. You are not solving anything. You are just rewriting. Then, so, okay. The other ones, these aren't as easy for me. So the way that I start with these is I always start with that base. So I start with the base, and I know that it will always be log of that base. And so I kind of work backwards to fill the pieces in. So I know it has to be that base, and I know that doing that little swirly thing, I kind of fill in the spots. So I know it would be 8 to the something power. So looking at what I was given, it's 8 to the second power. So it goes 8 to the second power on this side. So 8 to the second power is equal to 64. Yep. And sometimes it's helpful to put parentheses. You're just doing it backwards. So I want you to try to write the last one. 5 to the 0 power is equal to 1. So on your paper, I'd like for you to try and write that as a log. So you can always start out with the log part, and you start with that base. And just like an exponent has to be tiny and written up high, the base has to be tiny and written down by the curly part of the G. It has to be written low by this part of the G. That's where your exponent goes. It's tiny and it's written down there. So we start with the base. It has to go down here, 5. So 5 to the 0 power. So I'll put 0 on this side. 5 to the 0 power is equal to 1. Is that what y'all got? Okay, pretty simple. Like I said, you will have a couple questions on your quiz where that is all you do. No, it just helps, especially if like your numbers kind of blur together. If you put the parentheses or don't, like it's not right or wrong. Happy? No, my daughter drew it and it just says be happy. So last class I was out because my son had his baby. So she is precious and chubby and snuggly Rhaenyra. And I love her and I'm her favorite. So I'm super excited being Nana. She's got the snuggliest, chubbiest face. I'm so excited. She's my baby. Okay, so probably anytime you want to get me off topic, you can probably ask me about my baby. On to the back. How do y'all feel so far about the front? Okay. We'll do better once we do some homework problems with it, I hope. So the front so far. The front so far is basically like already almost half of the quiz. So the front so far, everything that we've done so far, that's like pretty much half of your quiz. So the hardest part is what? The graphing? Yeah, because we hate graphing, right? Like it's a struggle. Well, the good news is there's just one. And if you can do the homework problem, you can do the quiz problem. It's just one. And basically, it's making that table. If you make the table, you're just plotting the points. On to the back. So up at the top, it says you cannot take the log of a blank number. This is the same as you cannot take the log of or you cannot square root a blank number. You cannot take the log of what type of number do you think maybe? Negative. You cannot take the log of a negative number. You cannot take the log of a negative number. It just doesn't work. And so I want you to see what the calculator tells you if you try and take the log of something. And so we've not really done much with logs, but the log button is down the left side of your calculator. So let's try and type something in. So if you press the log button and it's down the left side of your calculator, there is a log button down the left side, I think. Somebody correct me if I'm wrong. I'm just doing it by memory. The log button's down the left side. Just press log. And then you can put any negative number you want, -7, whatever. Type something in, and what does it tell you? It doesn't work. And so the answer to that would always be undefined. So we're going to say that that is undefined. That's how we'll answer that one. You can just say UND, it's undefined. Oh, yeah. Yeah. Any number, a negative number. I wanted you guys to see what the calculator tells you. So type in a negative number, anything. Exactly. And so when you see that, you need to know what that means. So don't assume you did it wrong. It's because you can't take the log of a negative number and we say it's undefined. Yes. Yeah. It will not work. You cannot do it. You cannot do it. Yes. You can have a negative exponent. That is definitely possible, but you cannot take the log of a negative number. So all of these problems you're going to be expected to do without a calculator. But you can do them with your exponent chart. So there is this property, and it says that if you have log of some base, and that base is equal to this, see how they're the same, A and A, and that A has some exponent, so it kind of looks like this. See how 10 and 10 are the same? Then the answer is whatever that exponent is, because if the base and the base are equal, they cancel out, and you are just left with 3. If the base and the base are the same, you are just left with the exponent. Well, when you scan over all the rest of these problems, do they look like that? No, so we have to do math magic and make them look like that. So what I want to show you real quick is that if I was to rewrite the first one, or here, I'll show you on the second one. We don't know what that equals, so we could say it equals X, whatever. It equals something. And if we take and we rewrite it, then that would be 4 to some power equals 64. Here's where your exponent chart is helpful. So on your exponent chart, for this one, last time when we used our exponent chart, we were going down the columns. Now we'll be going down the rows. So down the row, we're looking for when is 4 equal to 64? It's to what power? Okay, so I can rewrite that and say, so I can rewrite 64 and I can say it's the same thing as to the third power, right? Yes. Okay, so anytime that you have the bases equal to each other, so 4 to what power is the same thing as 4 to the third power? What does x have to be? 3. So these, if they're the same, they cancel out and you're left with just the exponents. For the third one, we could say that it's equal to some number. And again, I can use the swirly thing to help me rewrite it. So it's 9 to some power is equal to 3. Usually you have to look at the bigger number. So here I have, for this one, I changed the 64 because it's 4 to some power. For this one, I'm not changing the 3. I can't make 3 be 9. But I can rewrite 9 so that it's 3 to some power, right? This one? Okay, so here, first thing, all I did was rewrite it. So are you good with this step? Because all I did was 4 to some power is 64. Okay, so now I can easily solve this if I can make the bases the same. So like here, the base is 10. So it's always log and then down below is the base. You call that the base. This is also something that if you have an exponent, the big number is also a base. So here, if the bases are the same, then they cancel. Same thing here. If I can make the base the same, they cancel. And so I want to see, can I rewrite 64 so that it's 4 to some power? And so I can use my exponent chart to help me. And on your exponent chart, if you look in that row, you can see that it is the 64 is the same thing as 4 to the third power. And if the bases are the same, you can cancel them out and you just drop down the exponents. So for this one, do you see that all I did first was rewrite it 9 to some power is 3? Okay. But now I want these bases to be the same. So 9 is the same thing as 3 to what power? 2. So I write it as 3 to the second power, but there was already an x there, so it stays. Right now, 3 doesn't have an exponent, but it really is there. What is it if it's not there? 1. So it's the same thing as to the first power. Now, do the bases match each other? So I can cancel them. And when I cancel them, the exponents drop down. So I have 2x is equal to 1. But I want to know what x equals. So because there was already an x, and I rewrite 9 as 3 squared. So now I have to divide by 2. So x is equal to 1/2. And one way that you can kind of think about it is that here, the base is smaller than this number, so you come out with a whole number. Here, the base is bigger, so it has to be kind of a fraction answer. It has to be smaller. The next one. What should I do? Why? That's right. You can't take the log of a negative number. It is undefined. You cannot do it. The next one, I want to show you, and I'm going to show you just a different way to write it, but it's the same thing. So what we are trying to do is to rewrite the 1/3 so that it's a 3 to the something power. On the front of the notes, up here, remember that if you have a fraction, you can rewrite it as to the negative power. So we're going to use that super skill here. That 1/3, that is the same thing as 3 to the negative 1 power. And so it doesn't matter if it's written like that one. Doesn't matter if it's written like this or like this. When those bases are the same, then you're just left with the exponent. So again, you could have done this one the same way where you do 3 to some power is equal to 1/3. And you have to do 3 to some power is equal to 3 to the negative 1. So you can solve it like that. That's fine. It's the same thing. I would like for you guys to take a moment and try and do the next 3. So try it first on your own and then look over and see if the person next to you is getting the same thing. Talk about it. Yep. So that we're So if you take 3 and you want it to not be a fraction, if you rewrite it in the top, it becomes a negative exponent. So it's the same thing that we did here. Yes, 3 as a negative exponent. Yes, 3 to the negative 1 power. So like, and since the bases are now the same, you can mark them off. And the exponents equal each other. So do you agree that I can rewrite it like that? Table 3 is not the same thing as 1/3, right? But 1/3 is the same exact thing as 3 to the negative 1. They're equivalent. This and this, those are the same. So to give you
Oh, it's negative, right?
Yeah.
I could do any fraction like that. So sometimes it's helpful for us to go that way, and that's what we're doing when we're graphing. Sometimes it's helpful for us to go this way because we need bases to be the same. And so anytime that you take a number and you want it to be in the top, you have to make the exponent negative. Because right now this is to the first power. And if you write it in the top, it becomes to the negative power. Yep.
So I bring the 5 down and then
It would be x squared, right? Since 25.
So I don't know where that X came from.
Oh, I thought you had x.
Nope, you could say it equals X and then 5 to some power equals 25.
And then do I have to find 25 on the exponent chart?
Mhm.
So it would be
It's
x squared,
5.
right?
No, it's 5 to
5?
the second power.
Oh, all right.
So I think you're saying it,
Uh-huh.
but, or I think you're not saying it right, but I know what you mean. All right, I would like for you to check your work. And it's very important that you realize that either way that you kind of like to go about solving it, that these are the same thing. Sometimes you'll see problems, or some people really like just rewriting it and solving it. And so then you get something like this, and then you forget that if the base matches that they cancel. So you need to know that these are the same thing. You could solve them either way, that they mean the same thing. You don't get the right answer. Good job. We're almost done. So the last thing that we have to do are these word problems. And I know that word problems tend to stress us out. Don't be stressed. It's not a big deal. These are actually probably some of the easiest word problems you'll do all year. So this says an alien radioactive isotope has a half-life of 238 years. Who has taken chemistry? These are half-lives. So half-life of 238 years. If you start with a sample of 8 kilograms, how much will you have left in 100 years? Well, I am giving you this formula. And so I'll tell you what all of the pieces mean. So A, that stands for your final amount. A sub 0. So it's sub 0 because that's like how much you have when you start. So it's your initial amount. So this is also your starting, how much you start with. What do you think T stands for? Nope. Time. It's also another T word. H, what do you think H stands for? That's a good idea. That's a good guess. Half-life. Half-life. So for this, why do you think this base is a 1/2? Yes, because it's a half-life. That's why the base is a 1/2. Because it's a half-life. So let's go through and let's mark up the problem. So it says a half-life of 238 years. Well, that is H. Next, it says that you start with 8 kilograms. So if you start, that's A sub 0. How much will be left in 100 years? So what is 100 years? Time. So I'm going to plug all this in. So our final amount will be equal to what we started with times 1/2, and it's raised to, remember, exponents are little, it's hard when it's a fraction. That is definitely not something we can do on our head. So you have a calculator. We're going to type it in. Use parentheses. They are your friend. Did y'all get 5.98 kilograms? No? Who said no? Okay, so let's make sure we type it in correctly. You're going to type it in exactly the way you see it. You're going to type in 8 with parentheses around it. Then you're going to type in a 1/2, or what's the decimal equivalent to 1/2? 0.5. You can do 0.5, also in parentheses. Then you use the exponent caret. It looks like this. It's a little house top. To get up, and then you do the up arrow, and it makes a fraction. And the fraction you're going to type in 100 divided by 238, and then you can press enter.
Oh. How do I do it?
So type in 8 with parentheses, exactly the way you see it. Then the next you put parentheses and you've got 1/2, or you could type in 0.5. And then you have to do the exponent button. So the exponent button looks like this. It's called a caret. It's a little house top. And then that'll get you up high so that you can type in the exponent. And the exponent is 100 divided by 238. And then you can press enter. Did you get it? Victor, how'd you do? Okay. Did you get it, Josh?
I got 5.7.
Yes. Okie dokie. So that is one of the problems. It's really easy. You can just do something like that. The next problem, you have $1,000 to invest in an account with a rate of 8% compounded semi-annually. How much will you have in 5 years? I am giving you a formula. The one on your paper says plus or minus. It should have just been a plus. There are other formulas where there is a plus or a minus. So you use plus when things grow or they appreciate. That means you think the money's going to get bigger. You will use minus when things get smaller or they depreciate. So you use plus when you think things are going to get bigger. You use a negative when you think things are going to get smaller. On your homework, you have a question and it's talking about somebody's car that's depreciating. So when you use that formula, you need to use minus because you're depreciating. So on your homework, underline that word, depreciate. Depreciate means the opposite of appreciate. It's not a positive thing, it's a negative thing. So on your homework, question 20, if you underline the word depreciate, it just means use a negative. Please don't skip the word problems on your homework. That's what we tend to do. The word problems are not difficult. All right, for this one, let's figure out what the pieces mean. A, same thing, it's your final amount. The P is a special name for your initial amount. It's still the same thing. It's initial amount, but they call it a principal. Actually, it might be PLE. I always mix them up. I never spell the right principal. Yeah, I spelled it wrong. It's PLE. I spelled it like the principal of the school instead of principal amount of money. So it's PLE instead of PAL. It's also the starting amount. It's the same thing. R is your rate. But this is very important. So this is why I put a star. It has to be in or as a decimal. The N is the number of times that it compounds in 1 year. So it's the number of compounds in 1 year. T, what do you think time is, or T is? I just said it, time. But it's time in years. So looking at this problem, we have $100 to invest. What is that representing? Which letter does that represent? P, that's our principal or our starting amount. It tells you it is a rate of 8%. Is that a decimal? No, so we have to change it. So what is 8% as a decimal? Y'all are really close. It's 0.08. You got to move it 2 spots every time, 2 spots. So compounded semi-annually. Like a semicircle. How many pieces are in a semicircle? 2. It's a half. So semi means 2. And how much will you have in 5 years? So that we have all the pieces we need. Sometimes if it's a number that's easy to do in your head, like when I'm typing this in, I'm probably not going to put 2 times 5 because I know what 2 times 5 is. What is that? 10. And this is going to be a money answer. You can do second enter, it'll pop back up. You are correct. What'd you get, Grace? You are correct. You should get 1,480 and 24 cents. What is a fraction? Make sure that you type in 0.08 and not 0.8. So I can help anybody type this in. I'll come around and I'll help you check to make sure you type it in.
Yes.